All right, guys, Mr. Gucci here with problem number 5 from the ideal gas equation homework. These ones are hard, so there's a little twist in there to mess with you. All right, let's get rolling. All right, so in problem number 5, we have 3.388 moles of oxygen gas, and it's at a temperature of 26.415 degrees Celsius. Comfy, that's like a room temperature. All right, if the volume of its container is 6.57 liters, what is the pressure in the container in kilopascals? And here's a hint, all right? The reason why this is a hard problem is you can't do gas law problems in Celsius. You gotta convert it to Kelvin. So, anyways, off to the worksheet. Here we go. I got room here. Cool. Here we go. So, problem number 3. Now, I'm just going to jump right in and use the ideal gas law equation. Pressure times volume equals the number of moles times the gas constant times the temperature. Now, the temperature given in my problem here, the temperature given was 26.415 degrees Celsius. I need to add 273 to that to turn it into Kelvin. If you see a degree Celsius sign anywhere in an assignment, you got to turn it into Kelvin here. All right? So here I go. I'm going to start plugging in values. Let's plug in that temperature value first to get started, okay? So I'm going on a calculator, 26.415, all right, plus 273, and we get as the temperature, we get, the temperature is 299.4. All right, 299.4. That is the temperature. Meter. Yeah, cool. All right. Now let's plug in some other values from this problem. What else do we have? We have that there are 3.388 moles of gas. All right. So for moles, I'm going to plug in 3.388. Okay, what else do I have here? It says that the volume of this container is 6.57 liters. So for the volume, I'm going to plug in 6.57 liters. And it's asking me for the pressure. So again, I'm trying to solve for the pressure. And it wants the pressure in kPa. So I'm looking to solve for the pressure in kilopascals. All right, it's important to know what the pressure unit is because that determines what gas constant we use. And when I go to the worksheet to look, I see that the kilopascal gas constant is 8.314. It should also be in your notes. So the gas constant, 8.314. That's that 4 and that 3 suck. 314. Better. All right. Okay. So in order to solve for the pressure, I'm going to divide both sides by the volume. 6.57. Boom. And over here, 6.57. Okay, so the pressure is equal to 3.388 times 8.314 times 299. I think I'm getting the sense this is going to be a big number, divided by 6.57. All right, so I'm going to plug that into a calculator. 3.388 times 8.314 times 299.4 divided by 6.57. And I get that the pressure in kilopascals is the pressure is equal to 1284 kilopascals. Now, This number is not quite as big as it seems because 1 atmosphere is equal to like 100-ish kilopascals, all right? So kilopascals are already inflated by about 100. So what this number actually represents is about 12 to 13 times Earth normal atmosphere. Still extreme, but like not insane bottom of the ocean, Titan submarine imploding with everyone on board kind of pressure. So we're looking at, let's see here, what was that number again? 1284. 1284. Gucci does not miss. 1284 kPa. All right. Good luck.